Yeah, it's a different approach. Yeah, but
even you talk about that.
yeah.
After the presentation.
Yeah.
Produce perfect.
Please. Oh, okay. So still we have to
Here.
share the. Okay.
Yeah.
Great.
I suppose there's
This for
my head and back.
Yes.
Okay. So still good morning, everybody. We are going to go deeper in something, let's say, alternative to the salinated water. And well, I'm not going to go much in deeper on water treatment technologies, but just a little bit about the state of the art in water regeneration. But as I think most of you are more familiar with desalination, I think it's good if I try at least at this first fast track school to introduce you the importance also of water regeneration and how it can be also combined with desalinated water. So this is the outline. So I will speak a little bit also like Pedro this morning on the motivation. Check the time. I would like to speak to you about the regulation because always in trying to implement new technologies, regulation is and policy is quite important if we want to implement those new technologies. And now we have a new regulation in Europe that obliges us to regenerate, and that's a further step on what we had before. I will speak about the advanced oxidation processes and photochemical processes. As we can say nowadays that they are almost somehow a state of the art also, because they are also quite known, but there are few advantages or new improvements that are required also. And I think we will focus more on that in the next fast track school. And then I would like to give you some examples, just to let you know how it works. So it is not new, and Pedro already mentioned that it's clear that the climate change is quite pushed by the exponential increase of population around the world. And of course, there is a high water stress all over the world. It's good because this morning already Pedro spoke about what we call the solar belt in the world, which is that those areas in the world that are which is here that are suffering more water stress. They have the highest solar availability for this kind of technologies based on solar energy. But it is also important to know that yes, our countries and this solar belt world, water stress is quite important. But the problem with water is also happening in those areas that water stress or water shortage is not the problem, but the water quality. So this is why in Switzerland and even in South America, in the Amazonia, they have also problems with the quality of water, which is also highly important for trying to implement our technologies. So everybody already, Pedro showed this, like more or less this slide. It is important to know that the water withdrawal, the more important water withdrawal is for agriculture, but also there are few people that know that the producing of energy, it is not only the nexus and water energy is also because we need energy to produce water. And we require energy, as you saw for the previous presentations, for the production of water from desalinated or brackish water. But we need also water for the production of energy. And that's another point that there's not everybody knows that. And it's also important to take into account. And of course, if we are speaking or we are trying to look for other resources, other sources of water and alternative sources of water, and we as population are increasing exponentially, we are producing also wastewater. So our urban wastewater, our municipal wastewater is increasing also exponentially. So why not using this kind of water? And indeed, we have to take into account that this urban wastewater, when we treat it, it comes out also with nutrients, with nitrogen, with phosphorus. So if we want to think on reusing this water for irrigation, and for crop irrigation. Of course, we don't need, if we use this water, we don't need to remineralize, which is what is happening with desalinated water also. So water reclamation would be a global need. It has, as it is mentioned here, different benefits from the environmental point of view, from the social point of view, and from the economic point of view. It is clear that if we use that water, we alleviate the pressure on this surface water extraction that you were mentioned also this morning. Of course, we have nutrients inside the water, so we could reduce the consumption of fertilizers. And of course, it is a reliable water supply because it is independent from the weather. Even more in those places in which the population is increasing in summer, we will have also more water available for this kind of resources. And in general, it requires lower investment costs and lower energy costs from desalination water, for instance. This doesn't mean that we have enough with urban wastewater. So the idea is that we have to combine both sources, because we wouldn't never have enough water if we reuse the urban wastewater. We wouldn't never have the whole required amount we need. But at least it is the technologies that are available and the improvements are cheaper and the energy costs are cheaper. So it seems logic to merge both sources, desalinated water and regenerated water. But if we want to regenerate water and we want to reuse water, we have to deal with two kinds of contaminants. Contaminants of emerging concern. These are quite fancy nowadays. These are contaminants that, due to the advanced analytical tools that we have available nowadays, these are not new. These have been present in water always, but now we have advanced analytical techniques that allows us to know that they are present. They are present in a very low concentration in the output of municipal wastewater treatment plants, in the surface of the waters. So they are present in the environment. And actually, there is another important issue, is that they accumulate in the environment, but they also can be photolyzed and they can produce, or they can be converted to other contaminants that could be even more toxic than the target one, the previous one. So we have to take into account that. And now there is something, well, now, no, it's also highly important, is the microbial water contamination. So traditionally, we have been always thinking on trying to treat the water and reuse the water, but thinking of normally only in disinfection, in the elimination of pathogens. And the thing is that nowadays we have another even higher threat, which is the antibiotic-resistant bacteria and antibiotic-resistant genes that are coming from the abuse of antibiotics from our side or from the animal side. So there's another highly important issue that we have to take into account. And the thing is that the antibiotic-resistant bacteria is not stronger or more resistant than the normal bacteria. But having the genes, the antibiotic-resistant genes in the media, that's highly important, highly dangerous, because they are transferring their antibiotic resistant to other bacteria, and they are quite complex to destroy, because you can imagine that destroy completely some pieces of a DNA is quite difficult. So that's a key point nowadays. So what about regulation? We have to take into account what I told you, is that we need regulation. Why? Because it is highly demonstrated that in this case, I'm speaking about contaminants, the presence of microcontaminants in the outlet of municipal wastewater treatment plants is highly important, because if you irrigate the plants with the crops with this wastewater, contaminants can be translocated from the soil to the plant and to the fruit. And this is how it could be the highest potential for uptake by plants, depending on the kind of crop. And if you see here lettuce, well, it's quite not clear, but lettuce, we consume lettuce raw, and they are present there. So that it doesn't mean that if you take lettuce, you are going to die. But of course, it's an important issue that contaminants are there. And if you use it in a long term, you could have some issues in the health. So, of course, then we deal with the pathogens, as I told you, and we have to take into account that there is not the same to inactivate or inhibit. So we have to take always into account that we have pathogens in the outlet of municipal wastewater treatment plants. If we apply a technology to destroy them, if we don't destroy them completely, they will regrow after a few time in a good conditions for them. So if we want to irrigate crops with urban wastewater, treated urban wastewater, then we have to take into account that if we are going to have storage tanks and we are going to have the tubes for the distribution of the water, there we can have a regrowing of the pathogens. So this is only like a general view of what we have to take into account. What about regulation? As I told you, nowadays, or well, before this European regulation, there are few of the countries that had regulation already in reusing water. Spain had its own regulation. There was also in Italy, in Cyprus, in different places in which the reuse of water was required. Now we have the new European regulation, which give us the minimum requirements of water quality for reusing in crop irrigation. It depends on if you are going to, with the kind of crops you are going to irrigate. In our case, in Spain, is much more restricted than the one that we had. And one of the more important issues is that the targets now is only dealing with pathogens. Though this regulation says all the member states of Europe must reuse urban wastewater. If they are not going to do that, they must justify why. And they must do a risk assessment and the validation of their technology, of each one of the technologies applied for what is called now quaternary treatment for the elimination of pathogens and contaminants. They have to validate those technologies with crypto, which is quite better than to use the chemical. So the thing is, there's a huge now issue with this regulation, which entered into force June last year. So for instance, in Spain, we are trying to implement those quaternary treatments now, because now in Europe, tertiary treatment is only nutrients removal or elimination, but when you want to eliminate pathogens or contaminants, it's quaternary treatment. So this is the regulation that forced us to reuse and to regenerate water. Regarding the technologies, all of us know that the well-implemented or commercial technologies, for instance, Switzerland is the only country that is being applying ozonation plus activated carbon, and they oblige to eliminate 80% of the contaminants, emerging contaminants, from the beginning of the wastewater treatment plant till the end of the quaternary treatment. They are the only one that have also legislation on contaminants. In Europe, we don't have that obligation yet, though the water framework is being also revised and it's going to go out with new contaminants. So the technology that we have, the people say, or people think that advanced oxidation processes that are based on the generation of hydroxy radicals that can be used with solar energy, with UV, and which are based on the use of semiconductors, I will speak about that after, are like innovative. No, they are not innovative. They are well known, they are well established, and the advances on them are in the production and the generation and the new catalysts, new materials, new semiconductors. And nowadays, a lot on using photochemical processes, trying to avoid the use of iron or hydrogen peroxide, of new semiconductors, and try to use things that were well known before, like chlorine, like peracetic acid or hydrogen peroxide, to eliminate the contaminants and the pathogens. So there are a lot of disadvantages coming from the commercial technologies like ozonation. Normally, ozonation has been widely used for the tertiary treatment or for the elimination of pathogens and for disinfection. There are a lot of disadvantages, so I leave you here a lot of them. One of the main problems is that when you want to apply ozonation and you have bromide or you have organic contents there, in the water, you can produce disinfection byproducts that could be more toxic and cancer and could provoke cancer. So the idea is try to improve this kind of processes to try to reduce costs because you need energy to produce ozone, and also to reduce the production of byproducts, disinfection byproducts. Regarding the photochemical processes, it seems that using UVC and the lamps is something highly useful, also highly used in the wastewater treatment plants as disinfection system. So why not to take advantage of those installations that are already there, that are already implemented, and try to improve them only adding some oxidants that could be hydrogen peroxide, could be sulfate with peroxide monosulfate or persulfate, or could be even chlorine that can be activated with UV, so you can reduce the costs and the required doses of UV. And even you can do something else, which is not only to eliminate pathogens, but also to eliminate contaminants. Because UVC 254 nanometers lamps do not degrade contaminants, only degrade those contaminants that absorb just in the same wavelength, which are very low number of contaminants. So this is also well established, well known, the solar heterogeneous photocatalysis with titanium dioxide. Pedro already told this morning that we are highly experts on the use of these kind of systems. We have been along more than 30-something years. We have been testing a lot of photocatalysts, a lot of semiconductors. These are materials in which you have to use the UV light, the photons from the solar energy, from the solar, for instance, to overcome the energy from the valence band to the conductive band. So the idea is to use not the thermal part of the solar energy, but the photons, the energy of the photons. So we don't use the thermal part. In that case, there are several drawbacks on using only titanium dioxide. There are a lot of people working, and that's the innovative point, on trying to improve the efficiency of titanium dioxide, trying to dope with other things like iron, nitrogen, to try to enlarge, also reduce the band gap, and also trying to avoid the recombination between the hydrogen, between the oxidant species that we have there, to not to lose the efficiency. So the innovation is here also. We will speak in the next fast track school about how this can help the performance. But mainly these enhancement strategies in solar photocatalysis are mainly, as I told you, to try to dope titanium dioxide to improve the result, but also trying to, and that's the future if you are working or you want to work in this kind of materials, it is to support these kind of materials in something that could be sustainably used and you can reuse in the system. And it could be also, well, there are a few things that you have to try to avoid. That's to lose efficiency or to lose the semiconductor. So I will show you like the next of the state of the art in the next school. And as I told you, just to let you know what is the future in this kind of processes, as I told you, is that to improve the UVC systems with chlorination. And then even we can use the solar energy here to activate the chlorine using the photons also, and that part of the UVC from the solar spectrum to eliminate not only the pathogens, but also the contaminants of emerging concern. So just some examples to finish. So we have here what is commercially available, which is the ozonation pilot plant. This is a PSA, but there is commercially available. And we have like an open photoreactor, which is called waste waveform reactor, and it's been highly used nowadays for this treatment of clean water, which is what is the outlet of a municipal wastewater treatment plant. So we can use, we use with the University of Almeria this kind of reactors. So we can compare the efficiency ozonation with solar photophantom. We can see that we can compare from the economic point of view, even the efficiency and the both, and how it becomes with the pathogens elimination, just to let you have some examples. And finally, though the regulation of the European Commission doesn't nowadays consider the elimination of contaminants, if we are thinking on doing the reuse of wastewater, we have to think on a technology, to integration of technologies that bring us the possibility to do both things simultaneously, to eliminate pathogens and to eliminate contaminants of emerging concern. We have some experience of that. There are a lot of people working on that. This is only an example in which we use even ozonation in this case. We tested the disinfection by products, the elimination of the organic microcontaminants present in real wastewater, and we also evaluated the elimination of pathogens and what happened with the cytotoxicity and phytotoxicity, because if we want to irrigate crops, we have to demonstrate that the water that we are producing and we are treating is safe enough for the irrigation of crops from the health point of view and from the plant point of view and growing plant point of view. So this is only an example of how we followed the degradation of contaminants. They disappeared, the disinfection, they were inactivated also, but then appeared some disinfection by products that are bromoform, allacetics, and we can see how if we continue applying ozonation, we reduce that. But this is from the commercial point of view. I mean, here, the dosage of ozone is quite high. So now the next step is trying to reduce this dosage by combining with solar energy, by combining with catalysts, by combining with oxidants. So to finish, only some key message from my point of view and from my side, which is the water scarcity and bad water quality are the problems, not only water scarcity. There are different technologies that can solve the problem. So we have to think always what is our, let's say, it is not the same to treat the effluent of a municipal wastewater treatment plant from a big city that from isolated areas, in which we can also apply those small systems in isolated areas or in an island or whatever. We have to take into account that the main target is not now the pathogens, because there's not so big problem, but the contaminants and the resistance to antibiotics. And of course, we have always need to do the risk assessment studies to be sure that the wastewater that we reuse is safe enough. And that's our group. So I thank all of them, because without them, it is not possible.
Thank you. For presentation. Maybe we have time again for one question or. For sure, what you have said, I mean, an integrated cycle of water is fundamental. So when you use primary sources, fresh water or desalinated water, after usage, it becomes wastewater.
Yeah.
So this is a crucial point. If we really want to reduce the scarcity, water scarcity, and we can mitigate it, provided that we do a proper reuse of wastewater. I think in Israel they are doing. They are pioneers. Yeah.
I mean, they are the ones that first used that we use it.
I think we.
It's another source that we have to take into account.
Yeah, for sure. I think we can. Okay,
so
thank you so much, Isabel, for this presentation, and now we go to the next presentation.